Example 2. So we're going to find the length of the curve y equals x over 2 to the 2/3 power for x between 0 and 2. So from our formula for length, or arc length, we do need the derivative, so start by finding that derivative. I'm going to go ahead and call it dy dx. In this case, our function is called y, and so our derivative here, using our power rule, 2/3 x minus 2 to the negative 1/3 power. And then I do have to do chain rule here. Derivative of the inside is going to be a 1/2. Okay? So let's make this look a little bit better. The 2's are going to divide out in the front and way back here. This is going to be a 1/3. And I have a negative exponent on a fraction. So what that would do, it was going to take my fraction and move it to a denominator. What will ultimately happen is it'll flip the fraction over when you think of this whole quantity x over 2 going into a denominator. So what you can do to rewrite this is 2 over x, and then that becomes a positive 1/3 power. Now, I'm going to stop right here because there is an issue. We are dividing by x, and if you notice, our values for x that we need to consider start at 0. And if we're going to divide by x, if we're going to end up plugging in x is 0, this is going to be undefined. So our derivative is undefined at this value for x, and so this won't work. We can't plug in 0 when we need to into our derivative. However, there is still an option, and so the option is going to be to rewrite our function in terms of the other variable. Right now it's written as y in terms of x. We're going to swap that. And so all that really requires is just solving for x back here. So we're going to take our function. I'll go ahead and walk you through the algebra on this. And we're trying to get x, solve for x. So I'm going to undo the 2/3 power first of all. And you can go ahead and do that just by doing the reciprocal power. So if I raised this quantity to the 3/2 power, and I just do that to both sides, it will, think of it as like undoing this power here. And so on the right side, we get x over 2, technically to the 1 power. Over here, we have y to the 3/2, and then just times both sides by 2, and then we'll be able to rewrite our function. This is 2y to the 3/2 power equals x. And so now we're going to find the derivative again, but this time with the derivative of x in terms of y. And then that way, hopefully it's not undefined when we try to plug in one of our values here. So our derivative here of x in terms of y, use our power rule, bring down the 3/2. So 3/2 times 2y, subtract 1. 3/2 minus 1 is 1/2. And then let's make this look a tiny bit better. The 2's divide out. This is 3y to the 1/2. And the 1/2 power, remember, that's just representative of square root. So 3 square root y. And this is good. Square root of 0. Actually, we're going to have to change our limits of integration. But this is not going to be undefined for our values. Let me just go ahead and find my y values. Since we swapped from x to y, let's find those y values now. So what would have become our lower limit of integration was x is 0. So let's figure out what y is. So when x is 0, you can plug it back in here or back into the original is fine. Y equals, and I'll just write it out so you see it, x over 2 to the 2/3 power. This is just 0. So that's going to be our lower limit of integration. When x was 2, well, what is y? Y equals 2 over 2 to the 2/3 power. This is just 1 over 1 to the 2/3 power. This is just 1. So we have our derivative, we have our new limits of integration, and then we're going to plug into our arc length formula. So we have the length is the integral from y is 0 until y is 1 of square root 1 plus the derivative. So now I did swap to y, x in terms of y. So everything with a x is basically going to turn into something with a y. So this is like f prime of y here. So this is 3 square root y, quantity squared. And then also this is going to change from dx to dy because everything here is in terms of y. Okay, so the process is the same, it's just our variable, we switched it. And then let's see what we can come up with for our integration. The setup is done. This is just how do we integrate this. So integral from 0 to 1. In the inside here, this is just going to be 1 plus 9y, 3 squared, square root y squared, dy. And then you can use u substitution on this to finish this integration. So in our case here, if you say 1 plus 9y is u, then du is just a nice 9 dy. And so if you want to divide by 9, you get 1/9 du is dy, and we'll sub that in and figure out what this integral value becomes. So this is square root u, and then dy is 1/9 du. Okay, so I need to also adjust my limits of integration. What is u when y was 0? So that's 1 plus 9 times 0, so u is 1. What is u when y is 1, the upper limit? So that's 1 plus 9 times 1, so that's 10. So this is u goes from 1 to 10. Okay? And then we have just a tiny bit more steps to do to finish this off. This now length is the integral. I'm going to actually take that 1/9 all the way out front. 1/9 times the integral of from 1 to 10 for u of u to the 1/2, or square root u du. So this is, using your power rule, 1/9 u to the, add 1 to this, 3/2 over 3/2, evaluated from 1 to 10. Make this look a little better. 1/9, flip and multiply by the 3/2 times 2/3. And then I'm going to go ahead and use my radical notation back on here. A 3/2 power, or 3/2 power, let me make that clear that that's a 2. 3/2 power is a square root to the 3rd power. Okay, evaluated from 1 to 10. All right, so this becomes, let's see, 2 over 27 square root of 10 quantity cubed minus 2/27 square root of 1 quantity cubed. Okay, just from right back here. So that's 2/27 times 10, and then one more square root of 10. So this is minus 2/27. Final answer. And you can make this maybe 20, but that's good enough. This looks fine. And so that is our arc length.